Hello friends. Friends, before we study the first law of motion by Newton, it is very important for us to understand about some basic facts. In fact, before the laws of motion invented by Newton, other people also tried some invention. They also tried to design some theories in order to make it easy to understand. So initially it was started by Aristotle. Aristotle, actually what he stated, in fact, see, he was just a philosopher, he was a thinker, very good thinker, very good philosopher, we can say. But what he said, let's try to understand that fact. Aristotle stated that one needs to apply continuous force to keep any body moving. Means what? And to some extent he was correct also, because if we want to keep our bicycle moving, we have to apply continuous force. We keep on pedaling in order to keep our bicycle moving. So at first Aristotle looks correct, that his beliefs were correct. But actually later on Galileo, a very important actually scientist, he tried out some experiments in order to explain that how continuous force is not required in order to make that body moving. He gave some good examples. In fact, based on his experiments, he concluded some important statements. And later on Newton actually gave us three principles of motion, and they were said to be Newton's three laws of motion, for very important to study. Now, okay, Galileo, what he did actually, he actually took the help of this slope. He actually took the help of a wooden block, wooden slope, on which he took a ball to roll down. So he kept a ball on the top of this slope. He allowed the ball to roll down, and he started noting down some observations. Like, first of all, this is theta. Theta is nothing but angle. So we'll call it angle of inclination. Angle of inclination. Then here, if I call the velocity v1 at that point when the ball is actually starting to roll, at that point its initial velocity is v1 and here its velocity is v2. Now we will call this as a height of that wooden slope, and it is actually covering some distance. So this length on a slope will be called a distance covered by a ball when it is rolling down. So these are some basic quantities or the parameters we are going to keep in our mind before we understand the whole experiment. Like here, so what he actually did, he noted down that when ball is coming down, when it is rolling down, what is happening in the very first case over here, v1, that is velocity v1 is less than v2. Why? It is very much obvious also. How we can say that? Since it is actually starting to roll down, its initial velocity will be less, but due to the slope, it is attracted towards the earth, towards the surface of the earth. It is going to come in motion. Motion is going to increase. It is actually going to be accelerated motion. In this case, he noted down it was accelerated motion. Accelerated motion, because since the ball was going down, it was performing accelerated motion, and due to that only what happens, v1 is lesser than v2. Okay, then in other case, what he noted down, when the same ball, same wooden slope is taken, actually the angle of inclination is same, that is theta. The height is also as same as it was here, h1, I'll call this h2, here I'll call this theta 1, theta 2. So even this actually length of slope was also same, that is taken to be d. Now what is happening? So he noted down, he was very keen to observe that if a ball is actually allowed to roll down on a slope, what happens? That actually it moves on, it covers the same distance. Remember, important thing to understand, friends, that it covers the same distance like this and like this. But here the situation is going to be different. Now in what terms? Like here what is happening, when a ball starts to move up, in fact it starts to move in upward direction, what is happening? In initial stage its velocity will be more, like this v3. If I call this, at here it is v3 and here it is v4, so v3 will be greater than v4. So what is happening in this case, since it is going in upward direction, it is going in upward direction, what is happening? At the contrary, its velocity is decreasing. And we know the change of velocity is called acceleration. Here it was accelerated motion, but here since initial velocity is more than the final velocity, so in that case we can say it is showing you retarded motion. It is performing retarded motion. The acceleration is decreasing. Acceleration, the change of velocity is less. Initial was more, final is less. In that case it is said to be performing retarded motion. Okay, so now what are the things, what are the facts we can actually derive from it? Now see, what is the prerequisition? The prerequisition is that two slopes must be as same in terms of the angle of inclination, in terms of the length of the slope and the height. These three things must be same for the two slopes to conduct this experiment, and Galileo carried it out in that way only. And he actually concluded that equal distance, the distance of a ball, in fact the distance covered by a ball on a downward direction, the same distance will be covered by a ball when it is going in an upward direction on the other slope of a same height and of a same angle of inclination. So that way what he was trying to say, in that case ball does not require any other external force. It does not require any external force to move in upward direction, since it was getting some sort of force when it was coming down due to the gravitational force. It moves in upward direction as long as it was having that length when it was coming down. So in that case what is happening, friends, that this d1 equals to d2. d1 equals to d2 means the distance covered by a slope to come down is equal to the distance covered by a ball to move in an upward direction. Both the distances are actually equal. Now friends, some other things can also be considered. What happens in this case if, there you see, this is actually the plane surface. This is actually the plane surface, and here I take the ball and let it move on the plane, okay, with a velocity v1. Now here at this point I try to note down its velocity, I'll call it v2. Now what can happen, what we can actually imagine in this case, if I call this as a frictionless plane surface, if I take this frictionless surface, then what we can actually conclude? We can say in that case, sir, v1 will be equal to v2. Why v1 will be equal to v2? Because ball does not require a continuous amount of force. It does not need, the ball does not need, a body does not need a flow of force on it so that it can enable that body to be in motion for the time to come. So very important to understand, it was indirect, in fact it was the indirect indication from Galileo that a body never requires continuous external unbalanced force to keep its motion. But usually what happens in a day-to-day life, we actually need continuous external force in order to keep ourselves moving. But if we talk about one exceptional situation in which friction is not there, friends, see, the friction is not there, because friction is always going to resist against the direction of force. So if we think about a situation in which the friction is not present on the surface and a body is moving with a certain force which was given to it in initial stage, it is going to maintain its state of motion as it is moving. At any point on that surface, you will be able to see, if you will note down the velocity of that particular object, it is going to remain as same at any point of on that surface. Okay, so Galileo derived very important conclusions, and according to that we can say that these experiments, in fact these experiments really opened new doors for further inventions which were carried out by Newton. Okay friends, thank you.